connected. So, boom, there we go. All right, so quick introduction of Alex. Alex is an entrepreneur. He's doing independent research into the future of software, operating systems, computing, and stuff. Starting last year, he started publishing some of his experiments in a format called lab notes, which I'd highly recommend going to his website and checking out those lab notes. They're really well put together and contain a bunch of really interesting thoughts and concepts and ideas. So check those out. Also, he may not note this, so I will note it for him, that his work is community supported. So it's super important that we have sustainable models to support experimental research of the kind that Alex and others pursue. So if you like the things he's doing, consider being a supporter of Alex Monthly, and you can find more about that on his website as well. So excited to hear more about what he has to say. So Alex, let you take it away.
Awesome. Am I coming through okay? Great. Jess, thank you so much for that introduction. I certainly have the proclivity to toil away in silence. So Jess, I really appreciate you reaching out and getting me to kind of pull out of my burrow and come speak. So seriously, thank you. And thanks for pulling this together. I'm glad that this community exists. I've enjoyed, I kind of binge watched a few of these from the previous few months over the course of the last week or so. Yeah, so as Jess said, I'm going to talk a little bit about some of the stuff that I really like, personal computing, the operating system, looking at the operating system of the future. I'm going to hit on a little bit of kind of where my head's at on why that's important. It's kind of a hard thing to get your head around why something you were just naturally curious about and obsessed with is like deeply important, you know what I mean? So I've spent a lot of time kind of over the last like 3 to 6 months trying to figure out what is it? What are those things about personal computing that are important to me? So I'll definitely I'll start there, and then I'll drop into some higher level things on the future of the operating system. So I'm going to hit share screen. Give me just a second. All right, is this coming through well? We're looking at slides, great. And I'm gonna move this thing. Okay. So yeah, for future of personal computing. Work so far, as just mentioned, and I guess I would need to change what I'm sharing. Share. So as just mentioned, so this is my website. You can go to this later if you want. So as just mentioned, I've been publishing lab notes for the last year and change. You can poke through these. This is going to go into much richer depth on some of the things that I'm going to hit on today. I also published, there's a nice long article. You can explore that as well. I published that last June. And as just mentioned, thank you so much for the mention there too. I started a membership program at the beginning of the year, and just I think this past weekend, I published the first member magazine. And so a lot of what I'm going to talk about today comes from this first member magazine. But if you want to join and read and see a lot of this stuff broken out in further detail, check out that first member magazine. All right, and we're back on slides. Hopefully, looking good. Great, thank you. The thumbs up is very helpful. So the scope of the work. So I've been publishing my lab notes as I have been engaging in the general research project of exploring an operating system of the future. Now, what do I mean by that? What's the scope there? I'm looking at the user environment, so not kernels and drivers, but the environment that you operate within. And I am looking at your entire personal computing domain. Sometimes when I say personal computer, that's interpreted to mean just a desktop or laptop. But this work intentionally addresses your full personal computing domain. So in today's technology, that's going to be not just your desktop and laptop, but also, maybe a smartphone, a touch tablet, a voice-assisted device, that kind of thing. So that's kind of the scope. Okay, why does this matter? This may be a little bit preaching to the choir, but this way we can set what I'm going to share with you in the context of where my brain's at with some of this stuff. Why does this matter? So personal computers are amazing. I'm not impressing anyone by saying that. We all know that. But let's just give personal computers a second here. So this wonder machine is capable of helping us connect with resources to learn virtually anything already known, create new things, share creations with others, visualize, reconsider, and reconfigure your thinking, your information, your processes. And it's kind of an amazing thing that personal computers allow you to develop and explore your own thinking. Plenty of things help you to explore somebody else's thinking, but personal computers can give you living spaces to externalize, review, and expand your own thoughts on the things that matter most to you. That's a pretty incredible thing. And we're talking about fundamental pursuits: self-reflection, self-expression, discovery, exploration of curiosity, creation, contribution, connection. This is basic stuff, but it's some of the biggest basic stuff. And we've invented a thing that lets us do all of these things in ways never before possible, right? That's amazing. So personal computers help us to learn, think, tinker, create, contribute, and collaborate. Each of these is deserving of very deep exploration, but I'm going to focus today on the second one, think. Primarily, for two reasons. It underpins all of them, and it's the first one that my mind goes to when it looks at what's the new foundation for personal computing for tomorrow. So to help frame how we're thinking about this, I wanted to borrow an example from Donald Norman's Things That Make Us Smart. You might know Norman from The Design of Everyday Things. Things That Make Us Smart is another one of his books. Highly recommended if you haven't read it. If you have read it, this example will be a little bit boring. But for those of you who haven't, new example. So take the 9 digits, 1, 2, 3, 4, 5, 6, 7, 8, 9. They're each playing pieces that can be taken once. Two players take turns selecting 1 digit, and the first player to have any 3 digits that add up to 15 is the winner. So consider a game where player A takes 8, B takes 2, A takes 4, B takes 3, A takes 5. What should player B take next, right? So at first, this is a little bit maddening. The representation that we have on the screen is not at all conducive to solving this problem. If anyone tried to solve it, I assume you'd reach for a pencil and a pad of paper so that you can find a better representation so that you can try to figure this out, figure out what player B should take next. The representation is a little bit poor. Let's consider another game, tic-tac-toe, oughts and noughts, crosses and O's. I forget all the names that we call it throughout the world. But consider that you are playing circles. What do you play next? This one's much, much easier. At the next turn, circles, yellow circles, should play in the bottom right corner to keep the person who's playing X's from winning the game in their next move. Very, very simple, right? And as Donald Norman points out in the book, these two games are actually the same thing. If you arrange the 9 digits in this grid, every line adds up to 15. So you can represent the original game that we played like so. And here it's very obvious that player B should take 6 to keep player A from winning. If they had 6, they would have 4, 5, and 6 that add up to 15. How we represent things completely changes how we interact with them, and not just on external surfaces. How we represent things changes how we interact with things in our heads, right? Personal computing is increasingly where we externalize our thinking, where we model it, where we develop it. Getting the fundamentals right for the software we use increasingly means getting the fundamentals right for the ways we think. So finding better models for us to do our thinking with, both externalized and within our minds, allows us to literally think better. Figuring out how to best give life to our thoughts within our personal computing domain is incredibly important, because better representations lead to better thinking leads to better ideas, and better ideas are what modern civilization is made up of. To sum it up nice and short, thinking about these things is important because these are the things that help us think. So that's why it matters. Now, the next section is the entire rest of the presentation, rethinking the OS. So I'm going to share with you, for those of you who aren't familiar with anything that I've published yet, which I assume is most people, I'm going to share with you a little bit of the kind of fundamental concepts that I've been exploring in my lab notes. If you have seen my lab notes, you won't be bored for long. We're going to move right into some higher level principles after that the operating system of the future can pursue to help pull personal computing into its kind of next stage of life. So it's important to note these are steps forward from where we happen to be today. So these are not descriptives of what personal computing ultimately could or should be. Rather, they're steps forward from where we happen to be today in order to move towards finding the best that personal computing could be in the future. So the basic fundamental, the kind of atomic unit of meaning that I've been exploring in the operating system of the future designs is the item, right? So if you think about personal computing, your experience with personal computing is made up of many items of various types: emails, notes, tasks, podcast episodes, web pages, so forth. So items are the kind of the atomic unit. Items can reference other items, and references are used to compose larger structures. So a task list, for example, is an item that is made up of many task items. But this hierarchy exists only from one perspective. Each task can also be referenced by other items. So for example, a task that was in a list could also be on a date in a planner. And critically, items have no restrictions. You can use all items as freely as any other, regardless of type or source. So you can gather items of any type or from any source into a single workspace, or reference to them from a single parent item. And we'll return to this concept a little bit more in depth in a second. But so the basic fundamental, if you think about a to-do, maybe you're taking a note, you write a task in your note, maybe later you add that task to a list or a project or an area, and then maybe sometime later you put it on your planner on a specific date. That's one to-do item that is referenced from all three of those places. It's not copied or anything. It's kind of like transclusion, where if you complete it in one place, it's completed in all. It's not necessarily tethered to any one of those places. It's the same to-do item referenced from all of those places. So some examples in action of associating items. These examples are from some of my earlier prototypes that you'll see towards the beginning of my lab notes. In this example, we pulled a podcast episode into a note, but it's the podcast episode itself. So we can pause and play it while we're taking the note, for example. And I may not play all of these. In this example, we've dropped an email draft directly into our task list for the day. In this example, you've seen an item on your bank statement that doesn't make sense. You need to add a reminder to check into it later. So you're going to create a reminder, and you can pull the actual charge item from your bank statement into the reminder. And so now when the reminder comes up, you can open that item and see the additional information, phone number, that kind of thing. In this example, we have an event on our calendar, and we're going to pull assets into it. We're going to pull a PDF into it. We're going to pull a link into it, that kind of thing, so that when the event comes, when the meeting comes up, and the event item is presented by our operating system, we can access all the resources that we're going to need for the meeting right there in it. So these are kind of simple and kind of extrapolated examples to help break our minds into this world of itemization, references, that kind of thing. But let's take a look at a larger workspace. So this is, again, from some of those older prototypes that you'll see in some of my earlier lab notes. In this example, we are pulling items of any type from any source into a single workspace. So in the operating system of the future that I've been designing, there are browsing contexts. And this specific one is a browsing path. And in our browsing path, we can open items, a web page, a note, a to-do list, all in the same path. And we can kind of use them in conjunction with one another. Something that's really cool about those browsing paths, we can return to prior contexts or paths at any point in time. So these are non-volatile workspaces. So when we return to our computer, we can see earlier today, we were in this path exploring these things, and we can pick up on the work right where we left it off without having to worry about saving or losing anything. We don't have to keep windows and tabs and whatnot around our workspace. We can let this be one discrete workspace, and it's just automatically saved by the system. When did the tangent notes talk, I think, was last month. And Taylor, if you're on here, that was phenomenal. The kind of map or graph view that you had is killer, super interesting. And that kind of line of thinking obviously would hold very well in a space like this. Something that's kind of fun. This is just a fun little, if we accidentally put a task in a note, we can just drag it over. So again, since these are all items, and items can be referenced from anywhere, we can just move something from a note to a task list, for example. When items show up in a context together, they can be, the system can remember their association. And so these are known as associated items. So here we're opening a browsing path, a bunch of different items, a PDF, an email, a couple of different things. And when we return to that, we created an event at the end of that one. And when we return to that event, the system can automatically resurface those associated items. So when we open the event from our calendar, we can automatically pull back into the PDF or the email, for example. And maybe even more interestingly, when the notification comes up for the event, it can surface the associated items right in that notification. So if we're going to running a few minutes late for that meeting, we can just immediately dial into the email thread and fire off a reply. Something that's kind of interesting too, since because of associated items, if we're working on one space, we can just create a reminder in that browsing path. And we don't have to actually add anything to the reminder. When the reminder comes up, the system will automatically remember all of the things that were associated with it. And we can just easily click to open the full path from that reminder. And we really didn't have to do that much work at all to gain that functionality. And now we're picking back up right where we left off. So we've seen a couple of different things here, right? So we've seen browsing contexts, browsing paths. Browsing contexts could be anything, but in our example, we saw browsing paths. They could be, more mind mappy kind of things with overlapping cards, that kind of thing. They could be anything. But so we saw browsing paths. We also saw non-volatile workspaces with recent contexts. We can pull up our workspaces and pick back up where we left off without having to worry about saving windows and tabs and that kind of thing. We saw surfacing associations with associated items, and kind of at the core of it, we saw itemization, items of a type rendered by a view. Very importantly, we separate data from the services that supply them or store them and the interfaces that render them. Or to map it into the example that we've been looking at so far, we're separating items from the services that supply or store them and the views that render them. And when you separate items from the views and services, you pick up some really wonderful things. We just saw a bunch. We're going to talk about a few more. So for example, you can have swappable services. So if views, items, and services are untied, and I need to adopt a new service, maybe my workplace has a new service for connecting to our email system, I don't have to let go of the views that I use for handling my email. I can adopt their service. It provides email, draft, contact items, and I can continue to use the views that I use. Same thing with swappable views. I can swap out the views that may become stock with the system for views that I want to use on specific items. And we can also have unified views. So if we're getting messages from one contact from Slack and email and Twitter DMs, those can be pulled into one unified view because they're just treated as items within a system. This is an example of switching to a different view for a draft item. One more interesting feature. There's a lot of different features that you can see in my lab notes. One I'll pull out is capturing the transformation of data. So items are changed through mutations that describe how they change, how they're created, how they're updated, that kind of thing. And these things can be logged into an activity log for record keeping, recalling lost information, undoing some activity. The system can use this the mutations log to compile daily summaries that include important changes made to items on that date, such as completing a task, that kind of thing. But what's also really interesting is services provide not just items, but also actions that you can take on items. And as a result, you can very easily create automations that respond to mutations and use items from any of the services in your system. And the services can span everything from email to Amazon to anything else. And so you have these automations that respond to mutations and take some of the actions that are provided to the system. And this is obviously, kind of a power user feature, but one of the coolest automations is, and many users who use it might not realize they're using an automation, is user-defined notifications. So instead of third parties deciding what gets plastered on the front door of your device, you as a user get to define notifications. They are responses to mutations. So for example, if an item exists, is created, that is an email from a certain sender, you can set up a notification that responds to that, that mutation to create a notification on your device. So zooming out a bit, there are a number of properties that this operating system kind of aims at, and I think I've been up for 17 minutes. So I'm gonna hit some of the big ones in 3 minutes, and then I'll kind of skip the others so that we can head into discussion. So when software supports import and export, we typically consider it to be a moral steward of our data. But by data sovereignty, I mean something far greater. As a user, I should have the freedom to co-use and remix data the way I want. We just saw a bunch of examples. I want to reference different kinds of things, regardless of where they're from or what they are, from a singular parent item. I want to use them in one workspace altogether. I should be able to co-use and remix the data the way I want. What's interesting is this is kind of how we already think about personal computing. And where our current systems deviate from this arrangement are the places where we experience significant frustration. You know, we don't really think in our heads in terms of apps. We think in terms of items. Apps facilitate our connection to items, but where apps get in the way of our dealing with those items as we wish come some of the biggest frustrations for users. So itemization lets you reflect your thinking across your entire personal computing domain. And given what we talked about in the first half of this, that's no small thing, right? That changes how we can manipulate our thinking on external surfaces, but also in our own minds. A couple other kind of higher level principles that we're driving after with this. Higher level primitives for software development. So we are constantly, as a developer, I'm constantly redeveloping concepts like undo and redo, drag and drop. They're well-defined. They're always expected by the user. They're surprisingly complicated to build, and yet we're rebuilding them constantly. These are strong candidates for higher level primitives that allow the system to offer one consistent user experience without the need for the duplicative work from every developer on the platform. So for example, we have two kind of higher level primitives that we've talked about so far today. We have actions and items. So with actions, the system could automatically queue actions when offline. It could retry actions when following network failure. Services can provide actions along with an undo action for each action, allowing the system to give the user a consistent system-wide undo and redo experience. And with items as a higher level primitive, global features like drag and drop can just be built into the platform rather than every third-party developer having to build their own implementations or compatibility services to handle. More broadly, the amount of double work done by developers today is condemning. Simple things like you know, every app that has items in it eventually grows to let you add notes or reminders or other things to the items within it. Within an itemized OS, no app would need to do that. You could just inherently do that by the nature of the system. Further, by separating, you know, views and services, you know, if you wanted to offer a new way for people to interact with their email, today you have to recreate an entire IMAP and Exchange sync engine, which can take years to get right, make complete, make compatible with all the myriad of server implementations and protocol extensions out there in the wild. If you with the itemized OS, you can just build the views. You don't have to recreate the services. Or if you're rolling out a new protocol, a new way of accessing the data, you can roll out just a service. There are, I think I just crossed 20 minutes on my counter. There are a few others. Happy to chat about them. I can let me breeze through for anything super critical, and then we can open up for a discussion. So as a user, you get to move beyond the app. So instead of developers having to ship an entire mini universe app, in which, so like if you wanted to adopt spaced repetition, for example, you're downloading an app and you got to put all your data that you want to use with the spaced repetition software in that app. With the itemized OS, a developer could ship an item that allows users to attach spaced repetition reminders to any item in their system. So every new component kind of expands your system in a new dimension. Yeah, and if you want to talk about these things, ask about them. Representing thoughts in higher fidelity. How do we represent thoughts? Workspace sovereignty. You should be able to paint the darn walls if you want to. We live in our personal computing devices more and more these days. Accessibility and longevity are really interesting topics for an itemized OS of the future. Breaking the privacy usability seesaw, community contribution. Those are all the topics that I didn't quite get into So happy to break into to discussion from here.
Awesome, Alex. Thank you. Thanks a lot.
Let's have a round of jazz hands.
Lots of really cool stuff there. There was one question early on from Rob, I believe, in the chat of saying, would the paths themselves be items? So you're like, I'm sorry, would the workspace paths be items as well?
That's a great question. And yes, when I implement the systems, paths are items too. You can save the path as an item in a project, for example, which is a really cool thing. Yeah, good thinking on that one.
Rob, did you have anything to add to that? Sorry, I saw you have your hand up.
Nope, that was it.
Cool. All right, and Akam, you want to add? Go ahead.
Yes, thank you. Can you hear me?
Yeah.
Good. So thank you so much. That was fascinating. The UI, I love the UI and all the visuals, how you presented that. My question would be, I was thinking, like, when more and more, like, let's say apps would go on that level, or the operating system would go on that level, like the room for apps becomes a little bit blurry, because it's the user interface is more or less, on the operating system. And I was wondering, we were talking about paths. Where do you see maybe algorithms fit in? I mean, could it be that the app in an operating system like you described would be a very sophisticated algorithm surfacing certain items exactly how I want it, with some, maybe even proprietary mechanisms, and that's the app, and not so much, let's say, the user interface to write messages like in Slack, for example?
Yeah, I think exploring those things is really interesting. So definitely looking at how those pieces of utility can be brought in as specific components. One example, and this does tie it to the interface, but one example that I've prototyped so far is putting that thinking, those algorithms, into kind of system-wide views. And that's something I didn't even touch on today, but you can check it in my lab notes. So the idea is that if there was a better way to resurface kind of important things, that in theory you could simply ship a new context view. So all the views in the system are swappable, and so you could ship a new context view that does that better thing in that better way. And so there are a lot of little different pieces. So it does kind of break the concept of the app. It's almost like if you took an app built on Redux, but you took its components, right? You took its state and put it here. You took its actions and put them there, and took its UI and put it here, and allow them to come back into the OS through a couple of carefully crafted protocols. And so so there are a couple of different ways that you can plug in those new kinds of functionality, but that's something I definitely want to explore more of in the future. Making room for especially independent developers, third-party developers to explore their thinking and put new thinking into the platform is really key. So one mistake I wouldn't want something like this to make is to accidentally make the whole thing too rigid and no longer allow for kind of that decentralized best idea to pop up globally, right?
I see two questions here that I'll read out, but I stuck my hand out, so I'll put mine first, which is basically a question to you, how you think about the operating system in the context of most of humanity using mobile devices, where I would wager most of the people on this call are in fact using professional desktop computing environments, and the split between those two.
Yeah, so my work definitely does address the full kind of personal computing experience across all of your devices, and not just the devices that we have today. I'm kind of looking for some of those universal elements that help push us into the devices of tomorrow in a kind of bridge the gap in a more meaningful way. So for example, services can support technologies and interfaces that they don't even know about, that don't even exist yet, simply because they aren't tied to one specific interface. But mobile is something that I unfortunately I don't have any good demos of right now. Hopefully next time I talk, I will, if I get another chance. So exploring some of these things on mobile is really interesting, but it's something that I have definitely done kind of secondarily, just because as you said, a lot of people in this space, we're kind of looking at what this looks like on the desktop. So browsing paths, for example, super cool on the mobile. I have a couple of things on that I look forward to sharing in a lab note soon. So look out for that. But yeah, definitely ensuring that these concepts are based on fundamentals that map fully into mobile and into other technologies. I agree. That's kind of the intent of the work for sure.
There's 3 questions that I'm going to read out, and then Francois and Michael, and then we'll move on to the next speaker.
Cool.
So from
I'll
Jeffrey,
try to answer quickly.
How are items similar to different from files on a desktop file system?
That's interesting. So something I didn't cover, there's a special kind of service called item drives, and item drives are where items are stored or synced or shared even. And one potential way and item drives just need to supply items and mutations, and they can store sync however they want. And so one example, super crude item drive that I built in one of my earlier prototypes is every item is stored into a file. So I think items and files can find a lot of overlap, but I think you could also describe them as fairly different as well.
Orion Reed asks, as your work seems to extend beyond just design, is reaching for something a bit more foundational, what kind of new math would you like to see emerge to help yourself and others pursue these kinds of ideas? What would help make the ideas robust, shareable, etc.?
Oh, I would love to hear more on that question, but I guess it was in chat, so we may not get to. Who asked this?
Orion, I've asked you to unmute if you want to expand.
Orion, if you want to,
I can unmute.
Go ahead.
Yeah, let's see how to expand on that. Well, I mean, I guess I'm asking this because like I'm doing kind of more theoretical ended work and like trying to build up mathematics for like reasoning about digital representation and that kind of stuff. And like, so your work is like super up my street, and I just kind of wonder from like myself or like others in a kind of similar space, like what kind of tools would you like tools, like as in, tools for reasoning about this kind of stuff, like what would be useful, like, so, if you could invent like a science of something here, like, like a science of items or something, like stuff that doesn't actually exist, like what kind of stuff would be useful for you?
I only just started going down that line of thinking in the last few months. I hope if you reach out, I would love to chat sometime, because I'd be very curious about your perspective. So please reach out. I've only started exploring that line of thinking recently. It's interesting. So the underlying data model obviously is inherently a graph. One of the problems with saying the underlying data model is inherently a graph is a bunch of people then immediately picture the graph as the user interface, which doesn't make a lot of sense. It's not a very usable thing, especially when you're considering your full personal computing domain, and everything kind of relates to everything. And so as the underlying data model being the graph, I think there's some, and being, itemized, right? I think there's some interesting space there for what you're talking about, for new math, for new representations. I'd be super curious to chat about that with you and kind of see where we land, because I'm not sure. And I would love to find out what those kind of fundamental things are.
Okay, very quickly, Alexander Bundakwala asks, is most of this research coming from first principles or more inspired on previous work? If so, how do you situate this relation to Smalltalk or HyperCard or OpenDoc or CyberDog, et cetera, et cetera, et cetera?
On the first question, I'm not sure. That would probably be an unwieldy one to unpack, so I'm not sure. On the second one, exploring HyperCard, OpenDoc, Smalltalk, those are such interesting examples. And I think a lot of them failed for non-conceptual reasons, which is very interesting. I'm constantly trying to find what are the conceptual reasons why they failed. And I constantly turn up nothing. And I think that's so interesting. I hadn't explored them much early in my career. I've definitely explored them a good bit more in the last few years. And I think trying to find where the Venn diagrams overlap, and then trying to figure out in those overlaps, what led to the demise of HyperCard within its concepts, right? I think a lot of that's pretty interesting. Looking into those technologies, I think is something that maybe we need to do more of. It's kind of fun that now, because it feels like they all died a premature death, they hold this legacy within all of our minds, that kind of, if they had died on their own as, you know, products that just completely failed conceptually, we would have put the concepts to bed. But it's kind of fun that the concepts from those live on as, you know, as this ongoing legacy within our minds as we continue to think about the future of personal computing.
Okay, one more question, Francois, please go ahead. And hello, good to see you.
Yeah, it's been what, 10 years? Yeah. So I guess I kind of have two thoughts, but I'll stick to one if we're short for time. So the services stuff, like I'm very interested in that problem, I guess. So like a lot of these tools for thoughts, obviously bridging to all the other things you have to deal with. Like there's no getting out of using Slack, using email, or whatever. As far as I remember, when you were talking about services, you defined that's kind of ways of bidirectionally interacting with other systems so that you can, you know, think in your tools for thought framework. It's a very, I don't know exactly what the question is. I guess I'll say some concerns or some thoughts. It's very interesting how you do it. It kind of reminds me, like, how do you implement that? Because obviously, like, email has all sorts of crap. Like to make a bidirectional thing is like not going to happen, because you're eventually going to be like, oh crap, I need to implement Outlook to have bidirectional. So you have to set, you know, work on a subset. Maybe you can kind of detect, I don't know what this is. So like you'll have to go to Outlook to unpack that. So I guess I'm kind of curious if what you've kind of dealt with there in making it work when building services around something complicated.
Yeah, for sure. And email obviously is the most complicated piece of it. Luckily, I spent the first 10 years of my career building only an email. And so I kind of had a like 10 steps up on that one. So with email specifically, I learned the limits of what we can shoehorn into the existing protocols, IMAP and SMTP. They're further than most developers would assume, but they're definitely jankier than most developers would assume as well. Where I can't shoehorn into IMAP with, you know, an itemized OS, as you said, you can't bidirectionally link, you know, two emails from outside of, you know, Outlook. I've leaned on item drives to kind of be that kind of base layer of you know, item drives being this you always have to have one item drive attached to your system, and it's this service that kind of handles the storage or syncing or encryption or whatever for your for all of your items that you create. But I've also, like, tasks, that kind of thing. But I've also used it for kind of that meta layer on top of items like email, which are coming from a service that inherently, you know, IMAP is 40 years old, that don't support those kinds of functionalities. So it's kind of like a marrying the services of today with kind of an item drive to get at everything the user would want.
Yeah, no, that makes sense. I guess I don't think we should unpack this, but just maybe a future conversation to have is, I think when Orion was talking about sort of math, I kind of thought more like computer science. Like I get obsessed with E-writes, but it's very interesting how you solve security, I guess. Like any tool for thought, there's no way I'm going to accumulate all these like micro pieces of code from a bunch of people, because eventually that's just like a security hell. Like I shouldn't be putting my brain into that. So security models.
You're actually describing to what today's NPM environment.
Yeah. No, you can definitely argue that, well, it's not worse than now. So sure, but I'm also not. I agree. Sure. If that's the counter argument, I will accept that, because I do that all day.
Although I do agree 100%, I have a very hard time putting my personal information in services that I know nothing about. And so that's why I think the security model of, you know, separate our services from our views. For example, we can try out new, wild, weird views from unknown developers if we can trust that it cannot touch the services, that it can't send stuff to the cloud without us, you know, like that kind of thing.
Yeah. And I mean, that's just a fun thing to work on. It's like,
for sure.
Isolation.
Yeah, figuring out the right security model for compartmentalizing everything is very interesting, because if you can figure it out, then you can unlock totally new possibilities of things people can build, things people can try and use in their personal computing experience.
I think you inherently don't use a computer like you would.
Francois.
Yeah, moving on.
I will say, I think there's we pivot in a lot of different directions here. Alexander mentioned OCAP and capabilities. I'll drop a link into autonomous computing saying that it pretty much requires capabilities model rather than ACLs. So I think there's lots of interesting stuff there. Thank you so much. Amazing. Let's have another round of jazz hands.
Huge thanks for having me. Please always feel free to reach out if you ever want to chat about this stuff. Really appreciate it.
And Alex, you should definitely go back through the chat. I know you were talking, so you weren't able to like read through some really interesting stuff in there that I think you'll enjoy as well.
Awesome. Thanks, Jess.
All right, Jeff. So this is actually Jeff's second time at Tools for Thought Rocks. He was here back in August talking about bring your own client. Jeff is currently a PhD student in computer science at MIT. He frequently collaborates with Ink and Switch, who some of you folks have probably come across their articles, most recently working on Paratext, which is a CRDT for rich text. And he's working on some of the user affordances around that now, which is pretty interesting. But today, he's here to talk about Twimex. Oh, and if you really like the stuff that Jeff is talking about, there's a really nice podcast on Metamuse conversation with Jeff about like sort of the broader interests that he has. So if you want to hear more from him, definitely go check out Jeff on the Metamuse podcast. But Jeff, go ahead.
Awesome. Great to be back here and to see a lot of familiar faces. Yeah, today I'm not going to be talking about kind of my main sort of research agenda, but I'm going to be talking about sort of a thing upstream of that has been a huge inspiration to me, which is Twitter. So let me share my screen. Okay. Can I get a thumbs up if you can see that? Great. So let me put the zoom there. So yeah, today I want to talk about using Twitter to cultivate ideas. You know, I was thinking this is sort of a funny title because I feel like in this room, saying that sounds totally normal. But if you were to walk up to someone on the street and say, hey, I'm using Twitter to cultivate ideas, you might get some strange looks and, you know, people saying, oh, like, you know, what kinds of ideas are you talking about? I think, you know, there's sort of a little bit of a secret about certain ways of using Twitter that maybe differ from the public general perception of what Twitter is. And today I want to kind of dig into that a little bit. You know, I suspect that most of you are at least a little bit active on Twitter. For me, it's been a huge source of just, you know, ideas that have driven my work. And so I want to talk about a few aspects of that. The first one, I'm going to start with just some big principles of how should we think about Twitter. It's a really confusing service. What is it? Second, I'm going to dig into a bunch of very specific techniques that I use to get the most out of Twitter that I think you might, you know, enjoy using yourself. And I'll be demoing that in this browser extension I built called Femix, which sort of tries to make it easier to use Twitter in a powerful way. And then at the end, I'll just sort of step back and think about what we've learned. Okay, so what is Twitter? You know, if you go back and read about the founding of Twitter, it's clear that they had absolutely no idea what they were making when they made it. I don't think anyone really has one answer to this question yet. It's a lot of things. But for me, there's a couple aspects that I love. One is this this cafe vibe. To me, this photo looks a lot like the way I feel on Twitter when it's at its best. So, you know, there's people hanging out. You get this sense of kind of community, right? Maybe some of these people are regulars who see each other a lot. Some of them are just kicking back and smiling, having a good time. Some of them look like they might be having somewhat serious conversations. But there's really this sense of like a village. You know, seeing the same people day by day. I think that's really just a nice feeling, especially, you know, a lot of us have been at least partially holed up at home for a couple of years. I think Twitter is a genuine source of community that probably a lot of you feel this way too. But there's another part to Twitter that I think is very, very different from a physical in-person village cafe. And that's more of a Memex feeling. So there's this Twitter thread that was published by Connor, the creator of Rome Research, that was really influential in the way that I think about using Twitter. And he talks about sort of a different perspective on what Twitter is. The way that I kind of think about it is this drawing. So a lot of people, you know, if you first look at Twitter, what it looks like is this furiously rushing stream of ideas, right? Like you open your screen and you see the last 10 seconds of thoughts from around the world. And I think that's a very narrow perspective on what Twitter actually is. And on the right here, you see sort of a different structure, which is it's this web of ideas that are kind of slowly accumulating over many years, all interconnected in various ways. And the neat thing is that Twitter has a number of qualities that sort of accidentally make it a really good tool for building this web. In particular, thoughts are short. So each thought gets split up into a little independent block, and you can really easily link between blocks. You can reply to blocks, you can quote tweet and put blocks inside other blocks. And so just from those primitives, you can kind of hack the product and use it in a very different way. And so I started doing stuff like digging up my own old tweets and reading over them, replying to people's threads that they had written like 2 years ago, which is really confusing when you start doing it at first. But it's really fun. And I started playing with it and feeling that there was more potential here than was obvious at first. So yeah, for me, that's what I like about Twitter. I see it as a village cafe and a Memex. There was a challenge though, as I tried to lean into this approach, which is that the Twitter product team, I don't think sees Twitter this way. I don't really know what they see Twitter as, but I know that sidebar is incredibly annoying. I don't know if I've ever been more frustrated at a product feature. And judging from my timeline, it seems like everyone I know hates it. I would just log into the product and be like, bombarded with like weird news, basically. So I started thinking, there's kind of this tension, right? I wrote down in my notebook, this is like, I guess a year and a half ago now. The problem is there's these Twitter power users. Like I'm trying to spend my day on Twitter memexing, but this product isn't built for me. So I started thinking, could we make it better for these use cases? And so I started building this browser extension. This was like the initial prototype. It had this little search box where you could like type some stuff and it would search your own tweets with that keyword really fast. The point was you could be like reading someone else's thing and you think, oh, I want to reply with something I've written already. So you could look it up there and copy the URL and paste it in or something. That was the idea. And then I played with that for, I think a good like 5-6 months or so, just using it myself. Had a lot of fun with it. Eventually a couple people, I shared some like videos and people reached out saying like, hey, can I use that? I think Rob, who's on this call, was one of I think you DM'd me and said, I want that. And then I was like, okay, I should like package this up and send it to you somehow. And that sort of spiraled into a real thing. So I ended up launching this beta and said, hey, like DM me if you want to try this thing. And I got like 300 DMs in a day. It was like nuts. Pro tip, try not to receive hundreds of DMs, and the Twitter UI is not really good for managing that. Maybe an item-based OS would help. Anyway, this ended up becoming this extension called Twimix. And the goal of Twimix, again, is to just mod Twitter to make it easier to use Twitter as a memex for cultivating our ideas. And the thing about Twimix is everything you can do in this extension, you technically can already do in Twitter. It's just kind of hidden or difficult. So the point is to make it just more natural and easy. So now I want to demo a few of the techniques I use in Twimix concretely. I don't know, maybe some of you have already tried the extension. If so, you can think of this as like the onboarding video that I haven't made yet. Maybe there's some corners of Twimix you haven't explored yet or usage patterns. If you haven't seen Twimix, this can be your introduction. I'll share my browser. Okay, so this is Femix on the side here. You can see already on my timeline, I have my normal timeline in the middle, and then I have this sidebar, which defaults to random highlights. So what that means is it just shows me a random person I follow and shows me their most liked tweets ever. And what this is doing is like digging up old good stuff from the web and just putting it in my line of sight, right? I didn't have to do any work. And generally, as I'm browsing, I'll just kind of come across fun things in this sidebar and just start exploring there. You can also get highlights on a particular user. So if I click on someone's tweet, it loads some of their most popular tweets in the sidebar. And I find this really helpful as kind of ambient context. So when I come across someone, something someone has said, I just want to know, like, what's this person about? Like, what are they thinking about, right? And often, like here, Omar Rizwan came up, who's, probably some of you have heard of him. I can go look at this blog post that Omar wrote and see, oh, that's the kind of thing this person writes. And if I don't know them, I can, decide to follow them or whatever. Lots of good stuff bubbles up here. Now I will note, like counts are a very, sort of janky proxy for good, interesting content. You know, often you'll end up with like random jokes and stuff, which is fine. That's just the best signal that's Twitter has for us right now. So that's what I use. Let's see. The next thing I want to show, by the way, is let's dig into Omar's profile because we're here. There's a sidebar called Our Conversations, which shows conversations that I've had with Omar on Twitter in the past. And so for me, this is again sort of like helping that serendipity engine go of just resurfacing old stuff. When I'm on someone's profile, I can remember conversations we've had, and maybe these conversations will sort of reconnect with new things I'm thinking about now. It's all about, you know, this ambient kind of awareness of old stuff. Okay, so that covers sort of ambient serendipity. Now I want to talk about a second category, which is more active searching. I really think that people don't use Twitter search enough. I find it to be a shockingly powerful tool. So let me show you an example. Often these days, if I want to Google something, for some topics, I'll just Google it and add Reddit to the end of the search, right? That's sort of good for some topics. But imagine, you know, I want to learn about, like, let's say we're all here talking about tools for thought. I want to learn about tools for thought. I happen to follow a bunch of people on Twitter who talk about tools for thought a lot. So what I can do is just in Twimex type /follows and tools for thought. And what I instantly get is stuff that people on my timeline have said about tools for thought. And this is so much more valuable than Google to me because I know these people. Like, I know who they are. I have a sense of, you know, what expertise they have and what context they bring that makes these results incredibly rich. Now, obviously, often there's things that don't come up with any results because they're just outside of the niche of people I follow. But, you know, I can't recommend enough, like, searching people you follow on Twitter for a niche topic that is relevant to your community is just an incredibly good way to learn about a topic. I'll do this a lot with like emerging technologies. You know, I want to learn about, like, what do people think about Firebase? Like, what are people's hot takes? You know, and just learning about you know, cutting edge things that aren't really publicly that aren't in the conversation yet. There's also, I think you might have seen flash up, I can search an individual user. So here I'm on Omar's profile. I can say, you know, what does Omar think about, you know, spreadsheets, right? And this is someone who thinks a lot about spreadsheets. So I get to mine someone's thoughts on a particular topic over time. That's a really powerful tool if you know that someone's gone deep on something. Okay, let's see. So that kind of covers the second category, which is really actively pulling content out of this web using Twitter search more. And then the final thing I want to touch on is how to write in Twitter. So there's a style of tweeting that I find kind of fun. And it looks something like this, you know, start writing about some topic. And then you think, oh yeah, like, didn't I already say something about that topic? So in my case, it might be, you know, I don't know, have I said anything about tools for thought? I don't know. Okay, I guess I have. And what you see here is I'm writing this thread, and then in context, I pop over to my search bar and I can see previous things I've written. And if they seem relevant, I can copy the URL and just paste it in there to quote tweet that. And that establishes this link in the web where other people can traverse that link. I can traverse that link. You know, maybe I remember, oh yeah, like, you know, Jess said something interesting about this. I'm gonna find tweets from Jess. One nice detail that Twimex adds is the autocomplete for the from search is much better than Twitter's stock search. So in particular, Twitter doesn't let you type a name and then a space, but Twimex does. So I can type like Jess M to find Jess. And then I can say, you know, what's Jess said about tools for thought? Search that. If I find relevant ideas there, I can then copy those into my thread. I'm just like tending to this web, right? Like weaving together ideas. And the point of the Twimex UI is that it just makes it really lightweight to do this stuff while you're in the context of writing. So there's a keyboard shortcut Command/ that takes you right to the search bar, and it's instant. You don't have to like wait for a page load. It's just happening all in context. So, you know, I'd encourage you, if you want to give this a shot, just try writing a Twitter thread sometime and just remember related ideas as you go from yourself or others, and quote tweet them. And then when people read, they'll be able to, you know, dig into the archives, so to speak. And I guess, yeah, just to close on that point, I should mention, like, I didn't invent this style. I think, like, some of you may have seen, like, Connor from Rome or like Visa doing these like mega thread things. And I think it's a really fun pattern. This is just a tool to make it a little easier. So I'm going to switch back to my slides now. I want to talk a little bit about future stuff I'm thinking about in Twimix. These are just ideas that I'd like to build at some point. I think searching your own likes and bookmarks, there's no way to do that in Twitter. And so if you use likes and bookmarks as a way of tagging things you found interesting, there's no way to dig back through that content. I think that'd be really cool. Profile notes, like remembering, how do I know this person? Why did I follow them in the first place? If you could just write a little note inside Twitter, right? Again, maybe a place where an itemized OS would be nice, because I can just add notes to people's profile items. And then, yeah, curating highlights. You can pin a tweet on Twitter, but you can only pin one. It's a little limiting. And, you know, going back to that point I made earlier, most liked is a pretty bad proxy for quality, honestly. But if people could pin a few tweets that say, this represents me, yeah, maybe pin 5 tweets. This is what I want people to see when they visit my profile, not just like what I had for lunch today. Maybe that'd be cool. And a last meta point, though. Yeah, I'm thinking about ways to make this project sustainable. So far, I've just done all of this as like a side project. It's actually been a lot of work. Polishing something like this to a level of detail that makes it feel nice to use is hard. I had to rebuild like the entire UI to show a tweet, right? Because it's like in my extension, I had to, you know, implement the like button, all this stuff. So I'm thinking about making it a paid product at some point. I haven't quite decided how that will work. If I do make it paid, there will definitely be a financial aid plan, because I want, you know, students and people who can't pay to be able to use it. But I'm thinking about, you know, how do I make this a project that I'm invested in for the next coming years, you know? So that's a little bit about how to use Twimix, how I use Twimix. I wanted to close with a few reflections on this project in general. So the first reflection is I really do believe that tools can shape behavior. And the neat thing about browser extensions is they let us reshape behavior. So I was frustrated with how this website nudged me to behave. And because browser extensions exist, I was empowered to just tweak that a little bit. I'm still mostly using Twitter. It's mostly their product, but this sidebar has sort of nudged it in a way that I prefer. And I think that's a really powerful idea. The second thing is just, I want to say, you know, I'm really thankful for the Twitter community and many of you, I think, both for feedback that led to this extension being great. So many of the features in this thing were inspired by just like ideas from people on Twitter, but also, you know, so many of the research ideas that I'm pursuing in my academic work basically, you know, originated in conversations at the cafe, right? Which I think is just so cool. There's something precious here worth valuing. And then the last point, sort of riffing on that, I just worry about, how do we preserve this thing? Twitter's a big part of my life. It's frankly difficult to imagine it not existing, but it's kind of weird that Twitter is just a business, and it's not a particularly successful business at that. It could just, you know, go bankrupt, I guess, one day, or, you know, get acquired and go sideways. Who knows? And I think that probably connects with a lot of interest in this community around, you know, decentralizing Twitter, making this a public resource that we can rely on for the next 100 years, not, you know, just a short-term thing. So yeah, that's my talk. We'd love to have discussion and questions.
Round of jazz hands as I'm unmuted so that I can get everyone to. There was a question from Ivo. Give me just a second here. We'll put everyone in equal mode.
Yeah, it really does make it easier for Boris and I if you raise your hand in the interface, because we're having to scroll back through the chat to find your question. So if you have a question, please raise.
Ivo, did you want to? I'll just say, will the search find very old tweets? The API has a limitation about 3,200 tweets back, if I remember.
It finds pretty old tweets. Yeah, I believe the search API is not limited to going that far back. One like little detail is that the API I'm using in the browser extension is quite different from the API that's publicly available as the Twitter API. So that might be a difference.
Any other questions live for Jeffrey? I will ask a question, which is, speaking of making things continue to exist, you currently maintain this browser extension, you've got some users, you do this off the side of your desk as a fun little project. How can we make sure that this sticks around and keeps being able to be used?
Yeah, great question. In the short term, I think what I'd be curious about is if there are people here who use it, if you could just send me thoughts on, would you pay for this? If not, what would it take? Would you donate to support it? Like, what do you think as a user? What model would make sense to you? That's the kind of feedback I'm curious to hear. One potential route is, this becomes like a $20, $30 a year subscription or something. I think that's like the magnitude that would make it a really sustainable project, and browser extensions sort of require constant maintenance, and so I think there has to be some sort of like ongoing thing, but it's also just a sidebar on Twitter. It's not like a whole product, so I'm not sure that's like that. I'm not sure. Is that reasonable? I don't know. I would love feedback.
Either the most important tool ever for fueling your tools for thought, or completely worthless. Fun conundrum.
Exactly.
So that sounds like a great takeaway, and we'll actually poll the community as one of the takeaways for that. You've got a couple of people in the comments already. I'm willing to pay because I would love to just be your patron, with I think is another angle at the end of the day. And so everyone knows Jeff and I talked about this offhand already. So, but there's no right answer to this right now, I think generally. And this is another topic that we'd love to cover. That is the flip side of, I want access to all of my tools for thought forever, is okay, cool. How do we pay developers to do maintenance as JavaScript degrades? So Francois, let me unmute you. Go ahead.
I'm curious. So you have a bunch of people using this extension, or in theory you would. It'd be very interesting to see what can you get out of that. Because just in the past, I've seen people make extensions that end up allowing them to do things you can't do with like the default API. So I'd be curious. Do you think there's stuff you could do with that extra information? APIs basically don't let you do stuff like my friends most liked whatever. You might be able to just get that like in transit. So I'm kind of curious if you have thoughts or there.
Yeah, I think there are a lot of cool possibilities, and extension's a pretty flexible platform. Like searching likes, for example, Twitter doesn't have a way to search likes in the API or the product, but I have a plan for how it could be done in a browser extension, right? So I think there are a lot of cool possibilities. It takes some tricky engineering to do that kind of thing sometimes, but
wait, how did you make the list of top tweets by someone? That wasn't
that's just talking to Twitter's search API. It's just using clever. Twitter has a lot of advanced search operators, which are not very well known, but if you use them just the right way. So the way that works is it searches like, does this person have any tweets with over like 5,000 likes? Oh, they don't? What about over 1,000 likes? And it just like tries a bunch of searches. That's how that works. So
that list you make where you automatically show the top tweets from someone, do you think it's possible to can you see who liked a tweet? I guess I'm kind of curious if maybe you could kind of take the top list of tweets from the top tweets from someone and then filter it down, like so you have something, then see which were your followers were those likes were from. So basically switch it to like your follow list.
That's a cool idea. I like if people I followed liked it, that means it's higher signal or something. That's a cool idea. Yeah.
Francois, that's a really excellent question. I bet if you became a patron, then your ideas might have more weight in what gets implemented.
Yeah, I'd like to. Can I talk about that real quick? I wish that everyone would stop being kind of a hippie. We all want everything to be free forever. We all want that. I would pay for you to build things. I love the idea of paying for you building specific things. It's kind of like I would support you as a patron. I don't know. I guess I've been lazy and haven't your work's great. You've been on, you work on things I like. Just make things. I wish most of us would make just these little tools. I would absolutely be throwing $5 a month here, $10 a month. I think a tool like this easily, I'm a professional. Paying $20 a month for it, if it's good, is nothing. And I don't we all have bad attitudes. We want everything for free. I would pay $20 a month for this, no problem. If you made it good, it already seems pretty cool.
Cool, that's helpful.
Cameron, go ahead.
Yeah, so I was curious about your comments on what the Twitter team thinks or the direction that this project is going. I think this is a question when people work on plugins, or I have this question: do people ever hope that it gets folded into the main thing, versus like it really is very different? It makes sense to stay independent. So just hoping you could talk a little bit more about that.
Yeah, sometimes people have asked me, like, are you worried that Twitter is just going to build this? And my answer is like, not really, because Twitter is building for a mass audience, right? And I think this is a very, I hesitate to say advanced, because it's not that it's like, it takes like a degree to use it or something. It's just like a niche product, I think. It's a very particular usage of Twitter that I don't think this is something that 99% of Twitter users care at all about. And so I don't expect the Twitter product team to care at all about, the kinds of problems I'm solving in Twemix, honestly. I also think that sort of speaks to the browser extension point again around like, I don't want to I'm not going to try to convince Twitter to build this. It's just much easier for me to build it from the outside and give it to people who want it. And as Boris just put in the chat, like I have like over 7,000 people are using it currently. So I guess there's like some volume to the niche, but that's a tiny number of people compared to like Twitter doesn't care about 7,000 people, right? And so that's how I see it.
For just $1 a month, you too could make sure that Jeff works on this full time.
All right, I think we're about wrapped up.
Yes, absolutely. Another round of jazz hands. Thank you so much. Go check out Twemix, and we'll get those questions out to help inform some of Jeff's future directions.
All right. Next up, we have Dalton, who's going to be talking about some different things. So Dalton's currently working on an assistive computing device for people with disabilities, and he brings a unique perspective as someone steeped in both engineering, math, philosophy, as well as like moving into software and that kind of stuff. So the last few years, he's been exploring some different mental models that we're not as familiar with in the software world. We had a chance to talk about them a little bit on Monday. And so today he's going to be kind of laying out some of the implications of those mental models, specifically for tools for thought. So Dalton, take it away.
Awesome. Let me make this full screen. Do I get a preview?
A preview of?
I cannot see if my screen is showing.
It's not showing yet.
Here we go.
There we go. Got
Slow
it.
Start. Thanks for your patience. So yeah, nice to meet everyone. A lot of you for the first time. I actually, probably the origins of this talk would be in the Future of Coding Slack, where I've started hanging out more. I'm not going to go too much into my background, very brief talk, but my background, I did a master's in robotics. I studied bioengineering and have been working on assistive technology for a long time. And then kind of as a parallel thread have been for about 5 or 6 years now, kind of following first the Brett Victor school of thought, and then just kind of spreading out from there and exploring a lot of different things. So this past year has been very transformative in a lot of ways. I've been almost took a little mini sabbatical a few months ago and have just explored a lot of things. I wanted to share some of that. So that post was right before I actually finally read The Dream Machine, and I knew a lot of the kind of pieces of history, but it helped put a lot of things together for me. And one of the things that I thought was really fascinating was that Looklighter actually articulated this thing about modeling that I'd been kind of thinking in my own terms really, really specifically, and I haven't heard many people put it that way. So I thought it would be interesting just to kind of dig into that a little bit. Basically, this idea that communication is based around modeling, and that's kind of the core activity we do in engineering and design, all these different things. And I think it's kind of interesting that on the same page of his kind of famous essay on these things was one of the coinings of the phrase the dynamic medium, kind of moldable systems. And I really think that this other concept of cooperative modeling has maybe a little more meat on its bones. And so I think it'd be interesting to get into that. So I actually revisited some of Victor's really old stuff in prepping for this talk. And I hadn't realized that he had also talked about this very specifically and kind of explored it as this breakdown between information software, manipulation software, and communication software. Just bringing this in for reference, I think it's an interesting thing to maybe refer back to. And I was a little surprised at how, as he started getting into it, I started disagreeing with some of the ways he was characterizing things in a way that, you know, a few years ago, I wouldn't have really been able to articulate. And I think he's also, his thinking has developed a long way since then as well. But basically there was a bit of a skepticism about manipulation and kind of contrasting that with information software. So it's like, we want to make things that are less interactive because a lot of the times that gets in the way, which is true. But kind of this conclusion that most software is information software, I think is not, I think information is not a particularly useful word in a lot of these contexts. I think you really have to get behind what is information, what is knowledge, you know, how do we know what we know, and so forth. And I think kind of the modeling lens has a lot to say about that. Now, on the flip side, something that I want to bring in too is this, basically he kind of laid out in a few different ways, this kind of split in computer science between the basically the kind of formal mathematical side where you're looking at, I mean, he says it right here, kind of the difference between when you're actually connected to physical systems or when you're working kind of abstracted from the physical world. And I've seen this in kind of my experience on both sides, that there's as far as I can tell, there's not a whole lot of transfer over from the hardware world to the way that we design tools for thought and software systems. And I think there's a lot, I would love to see this community engage with some of that knowledge more. And I think even down to the level of things like language design, what it means to design ways of communicating effectively. And so there's this whole, one of the things that I think is interesting from the sorry, one sec. So one of the things I thought was most interesting from digging through a lot of Alan Kay's stuff was this little nugget about communication with aliens and the idea that all communication is ultimately grounded in something that's kind of universal, something that's about the physical world, something that you can hold on to no matter what experience you've had. And I think one of the things even more recently he's been talking about kind of at the end of his career is drawing inspiration from kind of the hardware side, the physical design side. And I think there's some things that are interesting to kind of just like research if you Google what he's been talking about. And I want to briefly touch on, before going on the hardware side, I think kind of the closest that we get in the software world is functional reactive programming. story for another time, but a lot of the system design stuff, I spent a long time thinking about functional reactive programming in the context of hardware design and making it easier to work with these systems. And there's all these very, charismatic and brilliant people who lay out all these really attractive things about it, but ultimately it hits a problem when systems cannot be designed from the top down. So kind of back in the ARPA days, there was a talk about command and control, kind of this DARPA mindset of like, we're going to design systems from the top down that we're making our systems do what we want them to do. And there are some important mathematical results to show why this actually doesn't work out in practice. There's just one of the things that's kind of surprising. Probably a lot of you are familiar with this to some extent, but the core result of chaos theory is that deterministic systems, even if you have a fully characterized system, just by being nonlinear, you can evolve to states that cannot be computed effectively. And I think more on the hardware side of things, you get very comfortable working with systems where you're expecting to observe and measure things, and you're expecting to have closed feedback loops instead of avoiding them at all costs. And there's actually a lot that we can say about these systems, a lot of tools that we've developed. And I think this is one of the nicest encapsulations of the basic controls equation for modeling dynamic systems and developing algorithms for working with closed loop feedback. And I think I think it's something that can translate to tools that help us handle that in a more effective way. I just want to touch on some other things, just kind of like that I've been thinking about. One thing that I was not expecting to come across this year, but actually some of Andy Matuszek's notes led me on a little excursion on the quantum computing side. And I hadn't really dug into this much about the kind of the deep ideas around reversibility and reversible computing. There's basically a very fundamental result that you have to use energy in order, any computation that that you can actually do something with is going to cost you energy. Whereas if you do reversible computations, you can theoretically, there's no lower limit for efficiency. And there's just some interesting implications there that I haven't heard talked about a whole lot. And real briefly, I think, like, again, we don't think about hardware design from that low level, but there's some really interesting stuff going on in like the low level chip design that shows how much lower power we can be if we think about computing from more of a hardware perspective. I feel like I'm kind of blazing through this. I'm gonna go to another category relevant that I think is pretty interesting, but basically on the artificial intelligence side of things, there's also a lot to learn from kind of like explicitly modeling the world. And we've been kind of in this, I guess, more like black box neural networks paradigm for a while. And there's been some really interesting research about kind of connecting back to, the 60s and 70s, there's a lot of interest in kind of like developing machines that think like we do. And that kind of, the disappointing results led that to be a very unpopular way of thinking for a long time. But there's starting to be some more really serious effort in this regard, and kind of we're showing some of the limits of neural networks and what you can do with them. And I only recently came across some of the work that Vicarious is doing, but I think this is a very good model for how we can take the world more seriously and model it and have better results in algorithms. There's also another kind of thread on this to highlight, but there's some really interesting stuff that Josh Tenenbaum's group is doing. And some of this that's more interesting for like kind of functional programming background is basically program synthesis. So it's an approach where you're trying to essentially develop a model on the fly. So our our learning algorithms are currently not super effective at developing models as they go. So the basic intuition here is that if you can, you're basically like creating algorithms that will learn as basically develop programs to model the world so that they can effectively respond to new situations. And there's a recent kind of explorations of some of these things by Francois Chalet, who proposed this data set called the Abstraction and Reasoning Challenge that I think very nicely kind of encapsulates what's very difficult for current neural network approaches and learning algorithms to do effectively. So it's basically these puzzles that are very similar to Vanguard problems. You've seen those in the past, kind of the geometry problems on the bottom right here, and worth reading up on, but these are, as far as I know, no one's really effectively solved them from an algorithmic perspective before, but they're very straightforward to do if you just look at them. And then another couple of things, I think this, there's an approach to kind of programming where you're not relying on abstraction and text as the fundamental interface of the computer. I don't think there's a, I think we've kind of accepted text as being this kind of the lowest level interface of the computer kind of by default. And I think there's some better, I think that if you take graphical approaches a little more seriously, not from a kind of symbolic visual approach, but from a kind of direct representational approach, I think there's some really interesting ways you can go there. And one of the best examples I've seen of this was the Viewpoints project from Scott Kim, which a few people have talked about. And I did pull these up on Twimex, but definitely should check that out afterwards. And then one other thread I was not kind of expecting was came across Mark Miller's work and the E-language and kind of OCAP systems. And there's some really interesting overlap with kind of some of the language design things I'm interested in, both just making things easier for end users. And it kind of like turns out that if you design systems in a modular way, you can also design them in a very secure way and kind of have this fine-grained breakdown of what you can do on your machine and on others' machines. And there was this project I don't know too much about, but I saw some interesting explorations they were doing with UI patterns I hadn't really seen before, called Sprightly, that's using the OCAP model, working with him, just kind of a touch point to research on. And then since I was kind of themed on modeling, I thought this was an interesting, this is a good place to end on, which is kind of a, I guess, snarky take on like just thinking about what we're actually trying to do with modeling. You know, what is the, what do you get if you model a thing by having a full copy, having a map that's life-size scale? I think like when it comes down to it, a lot of modeling is about compression. And we have an overabundance of information in the world. And we rely on things being very regularly patterned and finding those underlying patterns. And so this is why ultimately modeling is successful, because we basically function in a world where there is very high regularity, high patterning. And if you have to explicitly model to kind of take advantage of those underlying parameters. So I've not done a lot of kind of like speaking in these contexts. A lot of this has been kind of like a personal research thing, but I really appreciate the chance to share some of what I'm working on, and I would love to interact with more of you in the future.
Cool. Thanks, Dalton. Give a round of jazz hands for Dalton. So yeah, a lot there. Dalton, and then people have questions for Dalton, feel free to raise your hand. I saw there was some comments in chat. You're definitely, some of what you're talking about is definitely resonating with people, that things that other people have talked about. Dalton, I guess the question, you and I talked on Monday about this, so I was curious to hear, like, how do you see this, a lot of these ideas around modeling and the way that we think about systems and that kind of stuff interacting specifically with sort of like the tools for thought, community and the sort of set of tools that are sort of expected right now, sort of like, and to kind of set the context for the question, right? Like there's been some recent tweets and other things about like, here's the default stack of a tool for thought, right? It has to have bidirectional links, it has to have text, it has to have, blah, 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 blah. Here's like this set of features. And it's this very like software packaged view of what a tool for thought looks like. How do the things that you're thinking about, the floor, Michael, maybe you can find that Twitter post. So how does the ideas that you're coming from, how do those speak into sort of this software-based, feature-based community that's building tools for thinking?
Sure. So I'm very much in the middle of thinking through a lot of things that you can tell. So I don't really have, I don't know that I have things sorted out well enough to be able to just kind of like present a few takeaways. But one of the big conclusions that I'm coming to is that everyone's building these really interesting tools, a lot of really cool experiments happening. But I think things will really take off when we're able to actually run each other's systems inside our own systems. And so kind of what I mean by that is, and I think the OCAP model has a lot to do with this, but essentially, if you can kind of like run a system and have it kind of like internally sandboxed and able to kind of bootstrap and host each other's tools, and we can kind of like share. One thing that we were talking about last time was being able to, say in like a Roam style interface, you have some sort of graph linking all of your notes according to some different connections, and it'd be nice to be able to just experiment with different ways to lay those out according to different geometries or topologies or different metrics that you're interested in. And I think being able to kind of do that live and not think about, so maybe just like a concrete connection to some of the stuff I was talking about, but like CRDTs, for instance, are an example of what I'm thinking about being kind of far in the functional top-down direction, where you're like, the model is that everything is going to be eventually consistent, as opposed to every agent has their own model, and that you're kind of doing this dynamic communication system. So basically being able to, I guess, just like stopping kind of coming from the standpoint that there is a standard reference model and starting to respect kind of the individual models that are not only in users' heads, but also in each kind of component within the dynamical systems that we're designing and collaborating with, and being able to interoperate at a much finer grain level, I guess.
So yeah, I think that's helpful. Like maybe I'll try to summarize, and then I see Francois has a question. So summarizing what I heard from you then, like, it sounds like you're saying all of us right now have a different model of reality that we're carrying around inside of our brain. Like we have a different model for like how this meeting works and who the people are in it and that kind of stuff. And we don't actually need to converge on a singular model in order for us to have like meaningful conversation and for us to move things forward. Like we can all operate in our own model and our own domain, and there can be communication amongst those models, and progress can be made, and understanding can be different. And I'm sure all of us are taking very different things away from this talk, but that's not actually a problem. That's like the way the real world works. And I think what I hear you saying is that we seem to idolize like the single like getting to a single model and like trying to evolve towards that or build tools around that idea of like a single dominant model, as opposed to respecting lots of different models. Is that kind of what you're saying?
Yeah. I mean, definitely related. I think one kind of meta response to that is I right now I'm kind of like working 24/7 trying to get an actual practical incarnation of a system that does some of these things that I've been working through. And I think I'm one thing that I've seen over the past few years is just the complete difference between having working code and a working device that people can interact with and play around with versus just talking about things. And I've, especially when I'm getting kind of into these domains where I have, it's like learning a completely new vocabulary, not just for, and some things that are, one of the things that's been really, I guess, kind of trippy this year is I've been trying to think more essentially about kind of like knowledge and modeling and meaning and things like that. And when you start thinking about things that are not naturally at home with language or words, it becomes even more difficult to articulate in words. And I think one of the things that's one of the great advantages of computing systems is that you have a formal system, both on the modeling side and on the physical side. So these, basically the hardware has been kind of like formally verified and validated down to, you know, every component of the system has been specified at an absurd level of detail. And we've never had this degree of characterization of the underlying interface with the physical world. And that interfaces with the formal system that essentially, you know, all programming languages are well specified, at least at the bottom of the compiler level. So you can kind of like have a formally linked system all the way from kind of the underlying physics model to the language for interacting with it. And where we really kind of struggle is with the interface between that domain and the cognitive domain and how we kind of naturally think about these things. And so being able to, I guess, like the more that we can kind of impedance match how we work with how these systems work, I think the more effectively we'll be able to communicate about kind of challenging distributed topics. And I'm definitely like, I'm very much like looking forward to being able to actually kind of show and share something and like collaborate. But I guess the idea is to do something that's kind of piecemeal and isn't like one system to rule them all kind of thing.
Gotcha. Looks like Francois has a question. Oh yeah, I have to ask you and unmute. Sorry about that. Here we go.
So I have kind of more observations. I think I've been thinking about simulation for a long time. My background is game development for a long time, so I made a lot of physics engines. And my kind of like, I guess, programming mental model from having spent a lot of time in it was sort of first simulation. So simulations are way more about emergent piles of objects that like all affect everything. So functional programming is like the opposite. It's like, let's scope everything. Nothing's allowed to talk to anything else. I like then have spent a lot of times in functional. But I personally can't combine the worlds. I think there's like a way of using functional programming style to run a simulation, but it kind of feels the more I build it, the more that small talk type things, which were designed for simulations, are actually more like reality. They're phenomena of a bunch of objects bouncing messages off, like every object affecting everything. It's sort of more fits it better, but that's just kind of like a programming model thought. Another one, I've talked to, I think, Joffrey about this in our meeting about multiplayer. CRDTs also don't match simulation, because simulation is a thing running a bunch of constantly changing objects in a way that a human didn't change. So actually, I can't get into subtlety of this. It is not the multiplayer architecture to fit simulation, but I can get into that another time. So I guess a couple recent backgrounds I've been doing is I did a lot of robotics for 3 years, and then recently I've been doing a lot of acoustical control systems. I work at Bose, and a lot of I guess that was my takeaway. It's sort of, I think what you're starting to discover is, I think we all think simulation, you can just come along and simulate things and be like, well, one, you can't predict the future. You can predict the future of a program because you can run every version of a program. So like theoretically, some version, you could run a bunch of instances of a program and find bugs, but you can't find all bugs because of, the whatever theory, the one where you can't, incompleteness theory. No, not that one. The other one, I'll get back to that. It's interesting where simulation is useful. So one is simulation is good for finding where something breaks. It's not good for finding where something isn't, like proving it wasn't possible. But for like simulation is a tool, for instance, if you're making rocket engines or fluid simulations, you can quickly find out your rocket's going to blow up. You can find an example of your rocket blowing up, but you can't prove your rocket won't blow up. So, but it's a very important tool because it's basically like, I'm using this thing to help myself. One, I have to like program it or code it or mathematically model it. So it helps me think clearer, but you're just kind of converging on clarity, but maybe, you know what I mean? It helps you think more clearly, or it's another tool to think more clearly, but there's only so many things you can do with it. And I know for me, I bang my head against trying to be like, oh, I'm a programmer, you acoustic Simulink MATLAB people, I got you. I'm going to write a simulation and I'm going to solve your problems. And it's like, no, they like laughed until I finally internalized that physical systems are not programmable, basically. But I think a really interesting thing that's happening, two things I found that are really interesting that are happening is, one in robotics, the kind of transfer learning. I think there's this thing happening where people are realizing that if you there's been such a heavy investment in simulation that you can run a bunch of simulations and generate data examples for ML. So there's like this really fruitful stuff going on right now where you can have things learn in a simulation. But then you learn, but you have to then, when you're running in real time like a robot, you still have to like deal with reality, which is messy. So it's like a robot can learn a lot of patterns, but it still has to like actually use sensors to adjust to real world conditions. And I think that's really interesting, where robotics used to be limited until simulation. You can't actually, a robot sitting there reinforcement learning is like, takes forever. You have to run in real time. It's like a robot picks up a block, oh, fucked up, go back, picked up a block, oh, fuck. And every time you're doing it, you're kind of building another example of what worked or what didn't work. But I think it's really interesting that you can run simulation to, create 10 million years of robotic experience. And it's starting to be that actually does make your robots at least start from a more knowledgeable model, and then reinforcement learning can adjust to reality.
But two quick thoughts to that. Let's do is, first, one of the ways I think about kind of the functional side is like, it's almost more like materials design. Like you're essentially focusing on a part that you can make static, you're kind of, basically you're designing the part that you're going to interface with the physical world. And that's an important part of systems design. The same kind of applies in a different way at the level of like environment design, which is another important thing about designing systems that we can work with. And that's more of the Chris Alexander direction, and like kind of two different ways of getting at it. But the other is just like, as far as simulation, I'm increasingly understanding that that's like basically how I think we think about and reason about the world at a very low level. So one of the, as far as I can tell, one of the most kind of like fundamental human differentiators is that we are able to simulate possible worlds. We can, and basically we're just doing this all the time. So you're kind of, one of the kind of threads I went on this year was looking at, I guess, language and how I guess spatial language is. So kind of like I started, I mean, this is not a new observation at all, but just noticing how everything is kind of grounded in directions and analogies to physical interactions and so forth. And I think really it comes down, you can think about one of the guy Vicarious likes to give this example of, if you imagine like pounding a nail into the wall, you have a particular, you can ask like, okay, is the hammer like facing up, facing the way? You're basically imagining this whole scenario, and you're doing it in this way that's embodied. So you're kind of experiencing it as if you were there. And it happens at such a fine-grained level that we don't think about it, but even abstract kind of like logical symbol manipulation, things like that, you're doing the same process super quick. You're kind of like projecting a visual image and manipulating the symbols until you get to the point that you can just pattern match, recall, and then your kind of latent, your memories, your sense response loops basically replace the thing that you manipulated with something that's useful for you, and then you continue the manipulation process. So it's kind of like simulation and then just like sense response all the way down.
Yeah, I wonder how you turn this into a tool.
Francois, let me interrupt just real quick. Guys, we're almost 15 minutes over time. Really appreciate all of our speakers and everyone for showing up and asking great questions and really, really good comments in the chat. I certainly learned a ton and have a lot of stuff to look up. If y'all want to keep talking, Francois and Dalton, I'll stay on the Zoom for a little bit longer. And I noticed Orion also had a question. And yeah, Orion, do you want to ask your question before you need to leave, or you want me to read it out? But for folks, if you need to leave, go ahead and leave. It's totally fine. The rest of the talk will be recorded and will be up on YouTube if you want to catch the very end. So thanks for coming out. Orion, do you want to ask? Or you want me to read out the question? Can't unmute myself. That is true. That is absolutely true. All right, let me see if I can find you here. There we are. How about that?
Cool. Yeah. Hopefully this is a quick one. The general question is that you were kind of talking like broadly under the umbrella of a kind of more systems theoretic approach to things, right? And within that, you kind of mentioned you know, this kind of more agent based view of things where like each agent kind of has a different perspective and how that can be really useful with like modeling the kinds of things that we're interested in. And then there's also the kind of like the dynamical systems side of just like being able to model and grapple with systems that like have these really complex dynamics with how they change and like how you might create feedback mechanisms and like control systems and stuff, which doesn't by itself require like a kind of agent based view. So I guess the more general question here is like, if people here wanted to kind of go off and find the kind of the different fields and like the areas where this kind of work is happening, there's obviously like, it's such a big space. Like, how do you relate that kind of stuff to this? Hopefully that made sense.
Yeah, so I think there's a really nice overlap with the two that you can see just kind of in, this is, I mean, definitely beyond the scope of this conversation, but I think when we work with dynamic systems and control systems, and you're kind of doing the state space modeling approach, you're thinking very much about the kind of the system as a, you're not necessarily thinking in this kind of like agent-based way, but there is this implicit agent interaction happening where there's an observer, there's an agent who's modeling the system and interacting with the system. And you see that that's nicely kind of captured through the basically your actuation parameters, your control parameters, and then your measurements. And it is very instructive to see how I guess those control parameters essentially capture the entire like degrees of freedom you have over the system, and it's generally very limited. So everything we exert tremendous influence over systems through a very small number of kind of independent parameters that we can affect. So, you know, when it comes down to it, you can essentially, you know, you can move in a few different directions, but even that is kind of like you're directing volitional impulses directed towards these end effectors and so forth. But like what you can really do when it comes down to it, and as far as I can understand, is you can direct your attention, and then you can direct your kind of exertion of will, essentially. So it's kind of like that back and forth is essentially really the actuation parameters you have. And then the sensory feedback loops come in through our model to the measurement side. And then there's a nice interplay there. And that kind of goes back to that this is a little bit beyond my kind of background and pay grade, but like I think some of the stuff that David Wolpert is doing on kind of like what are the theoretical limits of like I guess what can an agent know, and some of it he's exploring kind of like simulation theory and how many independent observers there can be in a universe and kind of the thermodynamic constraints there. But there is I would just say like I guess one last thing is just there's a really nice groundedness to control systems and just kind of like that whole domain of engineering. It's very tangible. We have some very good results, a lot of tools to work with. And when it comes down to it, like a thing is doing a thing and you can actually see it happen in the world. And it's a much tighter loop to kind of getting feedback on your ideas and seeing whether there's anything to them or what you can refine, than kind of staying off in like abstract symbol manipulation land. So I like that as a kind of forcing function, even though they're both very well connected.
Interesting. Cool. Francois, you still have your hand up. Is that intentional or?
Oh, sorry. I mean, I guess I had.
No worries. All right.
I did have one thought, which was just.
Oh yeah, go for it.
I guess to keep coming, go back to. I guess I should more plug something. One of the tool for that I'm working on is basically very core simulation. It's about running emergent, run something and then study how it went, but more in like to communicate ideas, not to run acoustics modeling. So I think I'd be curious if are you thinking of making a tool, or you're saying you're kind of like right now you're in the, I don't know, you're in the discovery stage. You're not converging to thinking about like a tool using this knowledge you're developing.
Yeah, so I actually, as of maybe a few weeks ago, had enough of a, I mean, I was very much kind of like everything's on the table for the past few months, but I think I do have a starting point now. It's also tied to like, we're getting ready for like a phase 2 NSF grant. There's kind of some concrete work to be done and trying to like make that interplay in a nice way. So there's a school for children with cerebral palsy in Philly that we're working with, and basically one of their, there's a lot of different directions we could go with that, but I think being able to really quickly build some of these user-focused software tools, especially that can work with groups of people, not just individual users. And I think that's been like a really difficult, we've seen with like the CRDTs and so forth, it's just really difficult to make collaborative software with a small team and for a few people and for specific use cases. So a lot of the kind of local first software and stuff like that. I think more specifically, it's what I'm working on is I guess like I want to stay kind of an operating system level approach, but not really in terms of like hardware specific. It's more just like, it's more like a personal operating system. So just kind of like providing the basic, there's a lot of gaps in what OS primitives provide. OS primitives are kind of rooted in what was available at the time, that kind of like OSs got baked into what they are. And there's some just, it's difficult to build kind of like social level primitives into tools without relying on centralized platforms and so forth. So I guess that's one level that I'm working with, and also really trying to push the like not using text as the grounding model for system design. So what I'm working on is like, as a first step towards that, is trying to get to a system that can be bootstrapped in itself without a textual format. So kind of like an image-based, kind of like machine code representation. And so that's definitely a bit of a ways off before that would, but kind of in the spirit of that the viewpoints project that Scott Kim demoed. So that's, I was actually like, for the past few weeks have been started working on that, was kind of hoping we'd get to the point of something demoable by this, but still working on it, but making progress.
Awesome. No, it's really cool that you're really just going in. I think the center of what you're thinking about is not quite the center of the TFT community. So I like what you're doing.
Cool. All right, Dalton, thanks so much for coming out and kind of giving us that tour. And thanks for everybody for being here today. And I'm gonna go ahead and wrap it up here. See y'all later.
Thanks for hosting.